For 9 years, I had been a systems engineer on deep seabed mining platforms. 9 years of polymetallic nodule extraction operations, remotely operated cutting systems, sediment plume management, and the particular technical discipline that came with maintaining industrial machinery at pressures that would reduce a human body to biological material before the nervous system had time to register what was happening. Most people who thought about deep sea mining thought about the environmental controversy, the regulatory debates, the question of whether the manganese nodules scattered across abyssal plains were worth the disruption to communities that had been undisturbed for millions of years. Those were legitimate questions, and I was not dismissive of them. But they were not my questions. My questions were engineering questions. How do you maintain a cutting head at 4,200 meters depth when the hydraulic seals are under 420 atmospheres of pressure? How do you manage the sediment plume from nodule extraction so it doesn't travel outside the licensed operational area? How do you keep 800 meters of flexible riser pipe from developing a resonance oscillation that would shear the connection points at both ends? These were my questions, and I was good at them. I had spent 9 years becoming good at them, and the company I worked for, Pacific Seabed Resources, had promoted me to Chief Systems Engineer on Station Kestrel because of how good I was. Station Kestrel was a semi-submersible mining platform anchored by a spread mooring system 340 kilometers south-southwest of the Hawaiian Islands, operating in the Clarion-Clipperton Zone, on the polymetallic nodule province that stretched across the Central Pacific in a band approximately 4,500 kilometers wide. The CCZ, as everyone who worked it called it, was 4,000 to 5,500 meters deep across its operating area and contained the densest nodule field on Earth. Station Kestrel had been on station for 3 years when the events I am going to describe began. I had been on the platform for 2 of those 3 years. I knew Kestrel the way I knew all the platforms I had worked, from the inside out, from the electrical draws of every system to the mechanical signature of every pump cycle, from the resonance profile of the riser system to the specific acoustic footprint the mining collector made at different cutting speeds across different nodule densities. I knew the platform's sounds and its data and its behavior in all the sea states it had encountered, and I knew when something in that behavior changed. My name is Marcus Webb. I am 41 years old. I grew up in Christchurch, New Zealand, and I studied mechanical engineering at the University of Canterbury, and went into offshore resources because the work was technically demanding and the pay was exceptional. And I have never been a person who made decisions primarily on the basis of comfort. 9 years of deep sea operations had given me a tolerance for physical hardship and a very precise eye for anomaly. I knew when something was wrong before the monitoring systems told me. The way a doctor develops the instinct for pathology that supplements what the tests show. I want to establish that clearly because when I tell you what the monitoring system showed in the weeks before the event on January 14th, I want you to understand that I had already noticed something was wrong before the data confirmed it, because the platform had a feeling that I had learned to read over 2 years, and the feeling had changed. I noticed the change in mid-November. I did not have data to support it yet. I had the feeling that something in the deep water below Station Kestrel was different. I was aware that feeling was not an engineering term, and I did not put it in any report. I put it in my personal log, which I kept separate from the official platform logs. And I wrote down the date and the description. Something in the water below the platform is different. And then I waited for the data to tell me what. The first data anomaly was in the sediment plume monitoring system on November 22nd. The collector operated at the seafloor 4,200 meters below the platform, cutting nodules from the sediment surface and pumping them up through the flexible riser to the platform's processing deck. The cutting operation disturbed the seafloor sediment and created a plume of suspended material that spread horizontally from the collection site in patterns determined by the deep current regime. Pacific Seabed Resources operated under a license condition that required continuous plume monitoring to ensure the sediment disturbance stayed within the licensed operational boundary. And the monitoring system consisted of turbidity sensors deployed on the seafloor at 12 positions around the collection site, each one transmitting sediment concentration data every 60 seconds. I reviewed the plume monitoring data every morning as part of my systems check. On November 22nd, Sensor 7, which was deployed 340 meters southwest of the current collection site, showed a turbidity reading that was 23% above its baseline. The other 11 sensors were normal. I looked at the current regime data. The deep currents at 4,200 meters in the CCZ were slow and consistent, typically less than 5 centimeters per second, and the plume modeling software predicted plume dispersal with reasonable accuracy based on those current measurements. The plume should not have reached Sensor 7's position based on the current regime at that time. I ran the plume model with the current data and confirmed the Sensor 7 reading was outside the predicted plume boundary. I logged it and flagged it for the environmental monitoring team, who were required to investigate any out-of-boundary turbidity readings. The environmental monitoring team's assessment, submitted by the team lead Kora Nakamura the following day, concluded that the reading was most likely a brief current fluctuation at depth that had pushed the plume edge outside the modeled boundary temporarily. She noted that deep current regimes in the CCZ showed occasional brief accelerations, not captured by the regular current measurement cycle, and that a reading 23% above baseline for a single 60-second interval was within the range of documented current fluctuation anomalies in similar operations. She said she would watch Sensor 7 over the following days. I said I thought that was the right response. What I also thought, and did not say because the data did not support saying it, was that Sensor 7's 23% reading had not been preceded by any current acceleration in the current meter data. The current meters, which sampled at 10-minute intervals, had shown no acceleration in the hour before or after the Sensor 7 anomaly. A plume pushed outside its modeled boundary by a current fluctuation should have left a trace in the current meter data. It had not. I wrote that in my personal log. Sensor 7 anomaly, no current trace. The plume monitoring system logged a second anomaly on December 3rd. This time it was Sensor 4, which was deployed 280 meters north of the collection site. And the turbidity reading was 31% above baseline for 2 consecutive 60-second intervals before returning to normal. Sensor 4 was also outside the predicted plume boundary for that current regime. No current trace. I flagged it to Kora. She reviewed it and said the 2 anomalies on different sensors at different positions were interesting, and she was going to review the sensor calibration records for both. She came back 2 days later and said both sensors were within calibration tolerance, and there was no equipment explanation for the readings. She said she was logging them as unexplained anomalies under the Environmental Monitoring Protocol. I said that was appropriate. I also reviewed the raw data from both anomalies myself that evening and found something I had not looked for before, and something that became relevant to me only after the second anomaly. Both turbidity events had been preceded by approximately 40 minutes by a brief pressure fluctuation on the seafloor pressure sensors, not a large fluctuation. The seafloor pressure sensors were part of the geological monitoring array that the platform maintained to detect seismic activity and substrate instability in the collection area, and pressure fluctuations below a certain threshold were normal, background geological noise. The fluctuations that preceded both turbidity anomalies were at the low end of detectable, 0.04% of ambient pressure at sensor 7's event and 0.06% at sensor 4's. I would not have connected them to the turbidity readings if I had not been looking for a common preceding signal. The pressure fluctuations had originated from beneath the collection site, which was normal. What was not normal was their horizontal velocity profile. The pressure waves from geological sources moved outward from their origin in a radial pattern, spreading equally in all directions, losing amplitude as they spread. These two pressure fluctuations had a directional component. The wavefront was stronger in the direction of the subsequent turbidity anomaly and weaker in the opposite direction, not a geological pressure wave, a directional pressure pulse that had reached a specific sensor in advance of a turbidity event at the same sensor. Something had generated a directional pressure pulse at depth, below the collection site, and the pulse had moved toward a specific point on the sensor array. And 40 minutes later, the sediment at that point had been disturbed. I wrote that in my personal log. Directional pressure pulses, preceding turbidity events, not geological. I was careful in my language even in the personal log. I wrote not geological and I wrote directional. And I wrote preceding and I did not write the next word. I was not ready to write the next word yet. Platform superintendent was Jared Olofsson, 53 years old, from Stockholm, with 22 years of offshore platform experience across oil and gas, and the 4 years that deep-sea mining operations had existed as an industry. He ran Kestrel with the methodical authority of a person who had managed complex offshore systems long enough to know that the most dangerous thing on a platform was the impulse to treat anomalies as noise before you understood what they were. He was not an engineer by training, he was an operations manager, but he had the respect for engineering data that came from having seen offshore systems fail. I went to Jared on December 7th and presented the two turbidity anomalies in the pressure pulse analysis. He looked at the data. He asked Cora Nakamura to join us, and then the platform's geological monitoring specialist, a man named Dieter Hausch, 44 years old, German, quiet, and precise, who was responsible for the seismic and substrate monitoring systems. I showed Dieter the pressure pulse data, and he ran his own analysis while Jared and Cora and I waited. He took 40 minutes. When he came back, he said the pressure pulses were unusual. He said geological pressure pulses at those frequencies and that amplitude level did not typically show strong directional components. The Earth transmitted pressure in all directions from a seismic source, and the directional asymmetry I had measured was larger than geological sources usually produced at these frequencies and depths. He said it was not impossible for a geological source, a localized microfracture event, or a small void collapse in the substrate to produce a modestly directional pulse, but the directionality I had measured was at the upper end of what he would expect from geological sources. He said he would increase the geological monitoring array's sampling frequency and watch for further events. Jared said he wanted daily reports from Cora and Dieter until the situation was understood. He said daily reports from me as well. He said he was going to inform Pacific Seabed Resources Operations Director of the monitoring anomalies. He said he was not suspending operations, but he was documenting everything. He said that was the appropriate response, and I agreed with him. I went back to the engineering deck and thought about the directional pressure pulses and the turbidity anomalies and the thing I was not writing in the personal log yet. And I thought about the fact that the collection site was 4,200 meters below the platform, and that the pressure pulses were originating from below the collection site, which put their origin point at somewhere deeper than 4,200 meters. And the CCZ seafloor in our operating area was 4,200 to 4,400 meters at the collection site. But the bathymetric charts showed a feature approximately 6 kilometers southwest of the current collection site, where the seafloor dropped away into what the charts labeled as a deep basin. See maximum charted depth 5,800 meters. I had noted that basin when I reviewed the area charts during my first weeks on Kestrel. It was outside the licensed operational boundary, and we had no operations in it or near it. The collector had never been within 4 kilometers of its edge. I looked at the direction of the pressure pulses. The directional component of both pulses, the axis of greater amplitude, pointed northeast. Northeast from the deep basin toward the collection site. I went back to the personal log and I wrote, deep basin, 6 kilometers southwest, 5,800 meters. I wrote pressure pulse axis. And then I wrote the word I had been holding back for 2 weeks. I wrote origin. December produced 4 more pressure pulse events, each one logged by Dieter's enhanced monitoring array with the data precision that the higher sampling frequency made possible. Each event showed the same directional component, axis pointing northeast toward the collection site. Each event was followed, within a 35 to 50-minute window, by a turbidity anomaly on the sensor nearest the pulse axis. The pulse amplitudes were increasing. The first 2 had been at 0.04 and 0.06% of ambient. The December events were at 0.09, 0.12, 0.14, and 0.17%. Not large enough to be seismically significant, large enough to move sediment on the sea floor, apparently, given the correlation with the turbidity events. Dieter reviewed all 6 events and submitted a formal geological assessment to Jared on December 20th. The assessment concluded that the pressure pulse events were unusual, and their geological cause was unclear. He noted the directional component and the correlation with turbidity anomalies. He said the substrate below the collection site appeared stable, and he saw no evidence of structural risk to the collector or the riser system at current pulse amplitudes. He said the pulse amplitude trend, if it continued increasing, warranted monitoring. He said he could not identify a geological mechanism that would produce a persistent directional pressure pulse series of this character, and he recommended consulting an external geological specialist. Jared approved the external consultation and submitted the request to Pacific Seabed Resources technical team. The external geological consultant reviewed the data in late December and reported back in the first week of January. His assessment was that the pressure pulse series was consistent with a geological phenomenon known as fluid migration, in which pressurized fluid moved through the substrate from depth and occasionally generated surface-detectable pressure signatures. He said the CCZ had documented fluid migration events associated with hydrocarbon-bearing substrate layers, and he believed that was the most likely explanation. He said the directional component could be explained by the orientation of permeable substrate channels through which the fluid was migrating. He said the correlation with turbidity events was interesting and could reflect sediment disturbance caused by fluid venting at the seafloor surface. Seeing known phenomenon in fluid migration systems. He said the amplitude trend was worth watching, but fluid migration events were self-limiting and typically resolved as pressure equalized. He said he did not recommend operational changes at this time. I read his report and thought about fluid migration. I knew what fluid migration looked like in seabed monitoring data. I had worked on platforms over hydrocarbon-bearing substrates in the North Sea and the Timor Sea, and I had seen fluid migration signatures in substrate monitoring data before. They had a profile. The pressure signature of fluid moving through permeable substrate had a diffuse character. The wavefront spread as the fluid dispersed through the substrate, and the surface-detected signature was broad and irregular, reflecting the branching pathways of the permeable channels. These pressure pulses were not diffuse. They were sharp, high-frequency leading edge, rapid amplitude decay, the signature of a pressure source that was compact and discrete rather than distributed. I wrote that in my personal log, and I wrote, "Fluid migration does not explain the signature profile." And I wrote, "The external consultant has not seen the raw waveform data." And I sent a message to Dieter asking him to compare the pulse waveform characteristics to the documented fluid migration signatures in the CCZ geological literature. He replied the same day and said he had already run that comparison, and the waveform characteristics were not consistent with fluid migration. Though he said he had not included that comparison in his formal assessment, because the assessment was intended to document observations rather than exclude alternative explanations. And excluding fluid migration would have required him to propose an alternative mechanism, and he did not have one. I said I understood. I said what was the most compact and discrete pressure source that would produce a waveform with those characteristics at those depths and frequencies. He was quiet for a moment. Then he said mechanical. He said the waveform was consistent with a mechanical impact source, something physically striking the substrate or the water column in a compact high-force event. He said at the amplitudes we were measuring, that would require a substantial force applied over a brief duration. I said, how substantial? He thought for a moment and said he would model it and tell me tomorrow. He told me the next morning. He said the force required to produce the observed pressure pulse amplitudes at the source depth, accounting for propagation loss through the water column, was in the range of 40 to 80 metric tons of impulse force over a contact duration of less than 1 second. He said that was the mechanical equivalent of a very large object moving through water and impacting the substrate or terminating a rapid movement with sufficient abruptness to generate that pressure signature. He said very large object was imprecise, and he wanted to be clear that he was working from waveform physics and not from any direct observation. I said I understood. I said I was going to talk to Jared. He said he thought that was correct. Jared received the waveform analysis from Dieter and from me on January 8th. He read both documents carefully, and then he called a meeting with Cora and Dieter and me, and the platform's ROV operations lead, a woman named Felicity Osei, 38 years old, from Accra, who had been piloting and managing deep-water ROV operations for 12 years, and who had the particular competence of a person who spent her working hours in an environment where imprecision cost equipment and sometimes lives. Jared put all the data on the table. 6 months of pressure pulses, amplitude increasing, waveform inconsistent with geological sources and consistent with mechanical impact, turbidity anomalies correlated with pulse events, direction of pressure pulse axis pointing northeast from the deep basin 6 kilometers southwest of the collection site. And he laid it out in the order we had found it and said he wanted everyone's assessment. Cora said the turbidity anomalies were real and unexplained, and the correlation with the pressure events was too consistent to be coincidental across 6 months of data. Dieter said the waveform analysis was his best interpretation, and he was confident in the mechanical impact conclusion, and not confident about anything further than that. Felicity said she had been waiting for this meeting. She said she had been reviewing the ROV maintenance logs and the seafloor camera footage from the collector operations, and she had found something she had held until she had a context to present it in. She said she was going to show us footage from the collector's seafloor cameras. She pulled it up on the meeting room screen. The collector was a tracked vehicle the size of a small house, operating on the seafloor and transmitting continuous video from 4 cameras. The footage she pulled up was from December 19th, camera 3, which faced rearward from the collector along the direction of travel. She ran it at normal speed and then stopped it at a frame and said, "Look at the sediment behind the collector's track path, in the area we had already passed over." The collector had cut nodules from the seafloor and moved on, and the camera was looking back at the disturbed sediment in its wake. The sediment was settling the way disturbed sediment settled gradually, the suspended material falling back to the substrate in the slow drift of abyssal current. Felicity had circled a section of the footage in the lower right corner of the frame. I looked at the circled section. In the background of the image, at the limit of the collector's rear camera illumination, the sediment was moving, not in the drift and settling pattern of disturbed material. Moving. The sediment was being displaced by something passing along the seafloor outside the collector's light range. A disturbance wave in the sediment moving from right to left across the background of the image. Steady and continuous. The wave of displacement you saw when something was moving across a soft substrate in the dark. The collector's camera had not captured what was making the wave. The displacement wave moved across the frame and passed out of the image to the left, and the settled sediment behind it showed the long sweeping mark of something that had traveled across the soft substrate in a single path, and leaving a depression trace of a width I could not calculate with precision from the camera angle, but that I estimated at several meters wide, passing across the sea floor behind the mining collector in the dark, outside the camera's light range, leaving a displacement wave in the sediment, and a depression trace of several meters width, and then moving out of frame. Felicity said she had found 4 other instances of similar background sediment displacement in the collector's camera footage going back to October, all outside the light range, all showing only the displacement wave and the track mark, all in the direction that put the origin point to the southwest, toward the deep basin. I asked her what the track mark width measurements were. She said she had tried to estimate them from the camera geometry. She said the estimates range from 2.8 meters on the narrowest trace to approximately 5.2 meters on the widest. I looked at those numbers. I thought about something 2.8 to 5.2 meters wide moving across the CCZC floor and 4,200 meters depth in the dark outside a mining collector's lights, generating sediment displacement waves and substrate trace marks and directional pressure pulses that originated from a deep basin 6 kilometers to the southwest. Jared looked at the footage for a long time. Then he said he was suspending the collector operation pending further assessment, and he was calling Pacific Seabed Resources Operations Director. He said Felicity should prepare a full archive of all the collector camera anomaly footage, and Dieter should prepare a complete pressure pulse data set, and he wanted both ready to transmit within 6 hours. He said Marcus, meaning me, should document the full analysis chain from the November 22nd sensor anomaly through the meeting we were currently in and have it formatted for external review. He said he was doing this because he was the platform superintendent, and he had a duty of care to the crew and a duty of accuracy to the company. And those two duties pointed in the same direction, which was suspend the operation and tell the truth about what the data showed. I said I thought that was correct. Cora said she agreed. Dieter said yes. Felicity said she had already archived the footage and was ready when we were. Pacific Seabed Resources Operations Director was a man named Thomas Breyer, based in Wellington, who received Jared's call at what was 0230 his time and took it anyway, which told me he had been expecting it. He had received the preliminary anomaly reports through the normal reporting chain over the preceding months, and he had read them. He said he had read them and he wanted us to know that. He asked Jared the direct question, and Jared answered it directly, which was that the platform's monitoring data, considered together, was consistent with a large biological organism conducting repeated transits across the CCZC floor in the area of the collection site, with activity originating from a deep basin 6 kilometers southwest of the current collection position, with evidence going back to at least October and pressure pulse activity going back to at least November. Breyer was quiet for a moment. Then he said large in what sense? Like Jared said 2.8 to 5.2 meters track width on the camera footage, and 40 to 80 metric tons of estimated impulse force on the pressure waveform analysis. Breyer was quiet again for longer. Then he said he was suspending the collector operation, and he was going to contact the Deepwater Biological Assessment team he had on contract, a specialist firm that Pacific Seabed Resources retained for environmental compliance review. He said he wanted their assessment before any further collector operation, and he was going to authorize a deep ROV deployment to the basin using the platform's heavy lift ROV, which was rated to 6,500 meters, to conduct a biological survey. He said he was not going to conduct that survey without informing the crew of its purpose and the context. Because he was not going to ask the crew to conduct an operation without the information they needed to understand it. He said the crew's safety briefing was Jared's responsibility, and he wanted it completed before the ROV deployment. He said good documentation work and ended the call. I respected that. I respected the fact that he had read the reports, that he had been prepared for the call, that he had made the decision to suspend operations without being walked through the reasoning slowly, and that he had named the crew's safety briefing as a responsibility rather than as an option. The briefing happened the following morning. 41 crew and research staff in the main meeting room. Jared presenting the data in sequence. He was precise, and he did not minimize, and he did not sensationalize. He said the platform's monitoring data had identified an anomaly that was consistent with large biological activity in the vicinity of the collection site. He said the activity had originated from a deep basin southwest of the current collection position. He said collector operations were suspended pending a biological survey by the platform's heavy ROV. He said the purpose of the briefing was to ensure the crew had the information they needed and to answer questions. There were questions. Good questions. The questions of people who were intelligent and paid attention and understood the implications of what they had been told. The most direct question came from one of the nodule processing technicians, a young man named Aaron Fitch, 26 years old from Brisbane, who asked how large. Jared said the track width data suggested a body width of approximately 3 to 5 meters, and the force data suggested a large animal, specifics pending the biological assessment. Fitch looked at those numbers and then looked at the room and did not say the thing everyone was calculating. Jared said the platform was in no immediate danger. The activity had been ongoing since at least October, and nothing had approached the platform structure or the riser. All structural monitoring was normal, and the ROV survey would provide better information. He said if anyone had concerns about remaining on station, they could discuss it with him privately. 3 people asked to discuss it with him privately. He handled all 3 conversations and all 3 stayed. The heavy ROV, designation KR-7, was prepared for deployment on January 10th. Felicity ran the pre-deployment checks herself. KR-7 was a large vehicle, 3.2 meters in length, equipped with 4 high-definition cameras, a full acoustic sonar suite, manipulator arms, and a scientific sampling package. Its rated depth was 6,500 meters, which was sufficient for the basin target. Felicity and I reviewed the survey plan together the night before deployment. We were going to descend to the basin floor, run a systematic photographic and sonar survey of the basin environment, and collect any biological samples the survey identified. I asked Felicity what she thought we were going to find. She said she thought we were going to find the thing that had been walking past the collector for 3 months. I said I thought so too. I asked her what she thought it looked like. She said she had been thinking about the track width. She said 3 to 5 meters wide and 40 to 80 metric tons of impulse force implied a lot of mass. And mass at depth in soft sediment implied something either very heavy for its width or very long for its width. And she thought long was more likely given what she knew about deep-sea megafauna morphology. I said I thought so too. She said she wanted to go in with the lights at minimum power until she had the sonar picture, and she did not want to alert it to the ROV's presence. Before she knew where it was? I said that was good operational instinct. She said she had been planning operations at extreme depth for 12 years, and she had never once felt the instinct to go in quietly the way she felt it about this deployment, and she thought that instinct was worth attending to. I said I agreed with her, and I said it without qualification. The KR-7 descended on January 12th at 700 hours. I was in the ROV control room with Felicity and Dieter and Cora throughout the descent. The descent to the basin took 1 hour and 47 minutes at operational descent speed. At 4,200 meters, we passed through the level of the collection site, the lights briefly illuminating the flat nodule-bearing sediment of the CCZ before the ROV continued downward into the water column below the basin rim. The basin became visible in the sonar at 4,600 meters. its walls appearing in the echo data as the ROV descended toward the opening. Felicity had the exterior lights on minimum power, using the sonar to navigate. The basin walls showed in the sonar as clean and relatively steep geological features, normal for this type of abyssal basin formation. At 5,200 meters, we were inside the basin, and the floor came up in the sonar at approximately 600 meters below. Felicity reduced descent speed. At 5,600 meters, she brought KR-7 to a hover and ran the full sonar sweep before descending further. The sonar showed the basin floor in good resolution, flat, sediment-covered, typical abyssal basin morphology, and on the floor, distributed across what the sonar resolved as an area of approximately 400 meters by 600 meters in the southern portion of the basin, objects. The sonar return from the objects was strong, indicating hard substrate rather than soft sediment, and the objects had a spatial organization that the sonar image made clear even at 600 meters distance. They were arranged, not geological, not random debris, arranged. I looked at the sonar image and thought about the cable stories and the whale stories, and stopped thinking about them, and looked at the sonar image. The objects were large, the largest sonar returns indicating dimensions of several meters, and they were distributed across the survey area in a pattern that was not random, and that the sonar resolution at that distance was not sufficient to characterize further. Felicity said she was going to descend to 100 meters above the floor and then hover. I said yes. She descended. At 100 meters, she held station and increased the sonar resolution. The floor of the basin came into better detail. The objects were nodules, polymetallic nodules, the same material the collector harvested from the seafloor above. But these were different from the nodules of the CCZ upper plane. The CCZ nodules were small, typically 2 to 10 centimeters in diameter, and distributed loosely on the sediment surface. These were large. The sonar returns from the largest objects suggested dimensions of 80 centimeters to more than a meter, and they were stacked, not lying flat on the sediment, stacked in configurations that produced the organized spatial pattern visible in the sonar, piled into formations that varied in height from 40 centimeters to approximately 2 meters in the tallest structures. I looked at the sonar image, and the thought I had is that the small nodules of the upper plane had been here for a long time, decades or centuries or longer, subjected to whatever process had caused them to grow to these dimensions, and they had been moved and arranged into these formations by something that found them useful in that configuration. Felicity said she was going to descend to 20 meters above the floor and activate the exterior lights. I said yes. She brought KR-7 down to 20 meters and brought the lights up, and the camera feed showed us the basin floor for the first time in full illumination. The nodule formations were clear in the camera footage. I have described them as arranged and stacked, and that is accurate, but it does not capture the character of what the cameras showed. The formations had structure within them, internal organization, the larger nodules placed at the base and smaller ones above, the overall form of each pile not random but consistent within a type, as if each formation had been built to serve a specific purpose in a consistent way. Some of the formations had gaps in them, spaces within the stacked material that created cavities. The formations were not identical, but they were consistent. The same builder's approach applied across many structures. the same intentions legible in the material. Cora said quietly that she thought some of the formations were nesting structures. She said the cavities in the internal organization were consistent with structures built to contain or protect something. I said I thought so too. I said the formations covered 400 by 600 meters of basin floor. That was 240,000 square meters. And the density of formations in the sonar coverage suggested hundreds of individual structures. Dieter said, also quietly, "How long does it take a nodule to grow to 1 meter diameter?" I said decades was the short answer. The growth rate for polymetallic nodules was approximately 1 to 3 millimeters per million years depending on the source. He said per million years. I said yes. He said that the nodules in this basin were 80 centimeters to over a meter in diameter, suggested they had been here for an extremely long time relative to human timescales. I said yes. He said that whatever used this basin as its home had been using it for at least as long as those nodules had been growing to that size, which implied a continuity of occupation that was measured in millions of years and not in human ones. Nobody said anything for a moment. Felicity held KR7 at 20 meters above the basin floor, the lights illuminating the nodule formations, the cameras recording everything. Then the acoustic sensors on KR7 registered a change in the water column above the basin. Not a sound exactly, a pressure change. A wave moving through the water at depth from outside the basin, from above and to the north, from the direction of the CCZ plane and the collection site. A pressure pulse. The same frequency signature that Dieter had been monitoring on the platform's geological array, stronger than any of the previous events. The platform's array, which I was monitoring on a separate screen in the control room, showed the event at 0.34% of ambient, double the highest previous reading, and it was not originating from below the collection site pointing northeast. It was originating from within the basin, pointing upward and north. From below KR7. The ROV's sonar showed the basin floor beneath us, and the basin floor was different from the sonar image we had taken at 100 meters. The formation field to the south was the same. The northern section of the basin floor, the section beneath KR7's current position, had changed. The sediment pattern was different. The flat substrate we had seen in the initial sonar pass had a different surface now, not the smooth, uniform sediment of undisturbed abyssal plain. The sonar return had changed because the surface had changed, because something on the basin floor beneath the ROV was present that had not been present in the sonar image we had taken when we descended. Something was on the basin floor directly below us. I looked at the sonar image and tried to resolve the shape of what was beneath KR7 at 20 meters distance. And the sonar at that range in those conditions showed me mass and surface texture and a boundary, where the thing ended and the sediment began, and the boundary extended across most of the northern basin below our position. And I looked at the scale indicator on the sonar display, and I did not say anything for several seconds. And then I said, "Felicity, ascend." She was already ascending. She did not wait for my assessment of the sonar image. She was ascending before I finished the sentence. And I thought that was the correct response. And I also thought she had looked at the sonar image at the same moment I had, and had drawn the same conclusion. And that conclusion had produced the ascent without any deliberation at all. The ROV climbed. The sonar continued imaging below us as we rose. and the image below stayed consistent. The same mass, the same boundary, stationary on the basin floor as we moved away from it. At 200 meters above the basin floor, I asked Felicity to hold and run the full sonar sweep. She did. The basin floor showed a single large sonar return in the northern section. Size inconsistent with any of the nodule formations in the southern section. Boundary extending 40 to 60 meters on the long axis. Reaching to 25 meters on the short axis, lying still, not moving, having been there in that position from before we had known to look, or having arrived there while we were looking at the formations to the south, I could not determine which. I said, "Felicity, continue ascent to basin rim." She continued the ascent. I watched the sonar image below as we climbed. At the basin rim, 5,800 meters depth. I asked for one final sonar sweep looking down into the basin. The sonar showed the formation field in the southern section. The northern section was clear. The sonar return I had measured at 200 meters was gone. In the time it had taken us to ascend from 200 meters above the floor to the basin rim, the thing on the basin floor had moved, had left the northern section, had gone somewhere in the basin or below it, or out of the basin entirely in the 15 minutes of our ascent from 200 meters. I thought about 40 to 60 meters long. I thought about 15 to 25 meters wide. I thought about the impulse force calculation, 40 to 80 metric tons, and whether that force estimate was consistent with something of those dimensions moving through the water column at depth. And I thought, yes, conservatively, yes. And then I thought about the collector camera footage and the 2.8 to 5.2 meter track width estimate. And I looked at the sonar measurement of 15 to 25 meters wide. And I thought about what that discrepancy meant, and I thought the most reasonable explanation was that 2.8 to 5.2 meters was the width of a limb, or an appendage, or some portion of a body 15 to 25 meters wide, and that the collector camera had been showing me a part of the thing and not the whole of it, and that the whole of it was what the sonar at 200 meters above the basin floor had shown me, 40 to 60 meters long and 15 to 25 meters wide and old as the nodules that had been growing in the millions of years it had occupied this basin, as old as the substrate it moved across, with enough force to generate 40 metric tons of pressure impulse, as old as anything I had scientific language for, and possibly older. We continued the ascent to the surface. I called Jared from the control room at 1,200 meters and gave him the summary. He said he understood and was calling Briar. Briar received the call and listened to Jared and then asked to speak to me directly. I described the basin floor survey, the formation field, the sonar return, the dimensions, the pressure pulse from below the ROV, the ascent, the cleared basin floor at the rim. He listened. He asked 2 technical questions about the sonar measurement accuracy, and I answered them. He was quiet for a moment, and then he said, "It was lying there when you were at 20 meters." I said yes. He said, "It let you look, and then it left when you went up." I said the sequence was consistent with that interpretation. He said, "It wasn't hiding." I said the interpretation was that it had been present on the basin floor from before or during the survey, and had remained there while we were 20 meters above it, and had moved when we ascended. He said it let you see it. I did not reply immediately. I thought about what Briar had just said. Whether the sequence of events was consistent with an animal that had been resting on the basin floor unaware of the ROV until the pressure pulse disturbed it and it fled. or consistent with something that had been present and aware, and had allowed the survey to proceed and had departed when the survey ended. I thought about the pressure pulse originating from below the ROV's position, which Dieter had registered as the strongest event in 3 months of monitoring. And I thought about what generated a directional pressure pulse from below an ROV that was hovering 20 meters above the basin floor. I said I thought that interpretation was supported by the data, and I was being careful about what I concluded from incomplete information. He said he understood that. He said he was standing the platform crew down from operational readiness, maintaining safe mooring and not resuming collector operations until he had a biological assessment and a clear recommendation. He said he was going to contact the Deepwater Biological Assessment Contractor, and he was also going to contact NIWA, the National Institute of Water and Atmospheric Research in New Zealand, because NIWA had the deep-sea biology expertise and the institutional standing to characterize what the survey data described. He said the ROV footage and sonar data were to be archived and transmitted to him in full. He said good work. He ended the call. I went to the rail of the engineering deck and looked at the Pacific. It was late afternoon, the sun low and red over the water. The platform mooring lines holding Kestrel in position, above the CCZ plane, 4,200 meters below the keel. 6 kilometers to the southwest, the deep basin sat in the same dark it had always sat in. The nodule formations arranged in their millions of years configurations. The basin floor showing whatever the floor showed. Now that KR-7 was back at the surface and the lights were gone. I thought about the formations, the nesting structures, as Cora had said, hundreds of them covering 240,000 square meters of basin floor, built from nodules that had grown over millions of years. A basin that had been occupied long enough for those nodules to grow to those sizes inside structures designed to hold them. I thought about what occupied a basin for millions of years. I thought about the nodule growth rate, 1 to 3 millimeters per million years, and I backed the calculation out. A nodule that was a meter in diameter had been growing for 330 to 1,000 million years at those rates. I thought about what had been present on this part of the Earth's surface 330 million years ago. The Carboniferous period, early marine life, the first complex ecosystems. And I thought about something that had been in this basin for as long as those nodules had been growing in it, something that had watched the planet change above it for geological time, that had been here while the continents moved and the seafloor spread and the Clarion fracture zone formed, and the CCZ nodule province accumulated above its home, that had watched the first human activities on the surface of this ocean, and then the first human activities on its floor, the first cables, the first survey vehicles, the first collector, and that had sent a directional pressure pulse upward toward a hovering ROV that was 20 meters above it, and then lay still while the ROV surveyed its home and then departed when the survey ended, with a patience and deliberateness that the sequence of events implied. The patience of something that had been in this basin for longer than most geological features had existed, and that had no particular urgency about anything, because time was not a pressure it was subject to in any way that I was equipped to imagine. The biological assessment was completed in March. NIWA's deep-sea biology team reviewed the full data set and issued a report that I have in front of me. The report confirmed that the pressure pulse waveform was inconsistent with geological sources and consistent with a large biological organism generating pressure through movement or signaling behavior. It confirmed that the sonar measurements from the 200-meter hover were genuine, and the 40 to 60-meter long axis dimension was the correct reading from the data. It said the basin formations were consistent with long-term habitat modification by a large organism, comparable to habitat modification behaviors observed in smaller marine organisms but unprecedented in scale. It said the organism, based on the sonar data and camera evidence, was an unknown species. It said the implications of an unknown species of that dimension and apparent age of habitat occupation were significant and warranted further investigation under scientific protocols with appropriate institutional oversight. It said Pacific Seabed Resources collector operation should not resume in the area without a full ecological impact assessment and independent scientific review. The report did not speculate about what the organism was doing when it sent a pressure pulse upward at 0.34% of ambient from directly below the ROV. The report did not discuss what it meant that the basin floor was clear when we reached the rim. The NIWA scientists were precise people, and precise people did not put interpretations in reports that the data could not fully support. I understood that, and I respected it. Pacific Seabed Resources has suspended operations at Station Kestrel pending the independent ecological review. The platform is on anchor watch, minimum crew, the collector secured on the deck. I left the platform in February and I am in Auckland now, and I will go back when operations resume, if they do. I have stayed in contact with Dieter, who is on the skeleton crew, and he sends me the geological monitoring array data weekly. The pressure pulse events have continued. They are regular now, one every 3 to 4 days. Consistent amplitude, consistent direction. The northeast toward the position of the suspended collector on the CCZ plane above. The collector is not operating. Nothing is disturbing the seafloor above the basin. The collector is sitting secured on the platform deck, and the seafloor below is undisturbed, and the pressure pulses are occurring every 3 to 4 days, pointing northeast toward the position where the collector had been operating. I think about that regularity. 3 to 4 days, consistent. Not geological, not random, not the erratic signature of an organism moving through its environment. A scheduled interval. Something in the basin below sending a directional pressure pulse toward the position where the machine had been at the same interval, with the consistency of something checking. I do not know what it is checking for. Do not know what answer a pressure pulse at 0.34% of ambient receives when it reaches the CCZ plane and reflects back, and the thing in the basin listens to the echo. I do not know what the difference sounds like between a collector operating and a collector that has been secured and silenced, but I think the difference is detectable to something that has been listening to this sea floor for long enough to know what it sounded like before we arrived. I think it knows the collector is gone. I think it has known since January 14th, since the ROV ascended and the lights went out, and it moved to a new position on the basin floor, and the basin returned to darkness. I think the pressure pulses every 3 to 4 days are the thing I described in my personal log in November, before I had data to support it. And when I wrote the word origin and stopped, I think they are how it speaks to the dark, at that depth and across that kind of time. I think they are how it asks where we went. I think they are how it asks when we are coming back. The basin is 5,800 meters deep, and the platform is still on station 6 kilometers to the northeast. And the collector is on the deck, and the CCZ plane is dark and undisturbed. And 3 to 4 days from now, a pressure pulse will originate from below the basin floor and travel northeast, and reflect off the empty seafloor above the silent collector, and travel back, and the thing in the basin will hear the echo of an empty plane, where a machine used to work and will do what it has been doing for longer than I have adequate numbers to describe, which is wait, in the dark, in the depth, with the patience of something that does not experience time the way I experience it, that has been in this basin since before there was anything on the surface of this ocean to wonder about what was below it, that will be in this basin long after Station Kestrel has returned to port for the last time, and the CCZ license has expired, and the polymetallic nodules have grown back over the collector tracks in the sediment above, slowly, 1 to 3 millimeters per million years, until the surface of the CCZ plane is as undisturbed as it was before we arrived. And the only record that we were there is the echo of a pressure pulse, 3 to 4 days apart, traveling northeast to a seafloor that has closed over the evidence of us and returned the question unanswered. Still, after all the time it takes for the tracks to fill, it's still sending its pulse and listening for something that is no longer there to respond.